Hi everyone, welcome to this interesting class where we are going to discuss operation on sets. So we have done introduction to sets topic. If you have missed that class, please watch the video. It's in this chapter, and today we are going to be talking about very interesting that how do we operate on sets, or what are the operation on sets. And I'm going to make these concepts really easy. So let's go ahead and get started. Do check out the other courses on our website if you haven't done so already. We have physics, chemistry, biology and maths for CBSE and ICSE boards, classes 8, 9 and 10. We have physics and chemistry for Cambridge, classes 9 and 10, the IGCSE board. And if you guys want to learn coding, we have Java and Python coding for all classes. So what are the operation on sets that we'll be learning today? We're going to be looking at union of sets, intersection of sets, difference of two sets, and complement of a set. So let's go ahead and look at these one by one. So what do we mean by union of sets? Okay, so please take a careful look at the definition here. Union of two sets A and B is the set of elements which belong to A or to B or both A and B. Okay, so please take a look at this carefully. So they either belong to A, they are present in A, or they are present in B, or both. So we are taking a union. And how do we represent it? Using this U kind of symbol, A union B. So we read it as A union B. Now let's try out an example. Let's say you have set A contains 2, 3 and 4. So this is the set notation, remember the curly braces and commas. And B contains 1, 3, 5, 7. So can you guys tell me what is A union B going to be over here? So what will A union B be? Can you guys tell me? So when we are talking about union, union means basically like taking everything, right? Like we say a friends reunion, everybody is invited, okay? Or your school reunion, so all your school friends are invited. Same way union here, you have to take all the elements of A or B or which belong to both. So let's do that. So what is A union B going to be? So I'm going to take these elements that are present in A. So that's 2, 3, 4. Okay. And let's also take all the elements present in B, which are 1, 3, 5 and 7. But since I've already included 3 here, I'm not going to take it again. Okay, so I've taken 1 here, then 5 and 7. So what is A union B going to be? As you can see, we have written 2, 3, 4. So I've included all the elements from A and all the elements of B. 1, I won't write 3 again because remember in a set, the elements need to be unique. 5, 7. Okay, so this is A union B. Now usually you will write it in increasing order, but remember in sets order is not important. So you can even represent it like this. Okay, so if we write it now in order, A union B is going to be 1, 2, 3, 4, 5, 7. Okay, so please check in your school whether they want you to write it in order, but this should be fine. This is not wrong. It's just that this looks nicer and more readable. So is it clear? Elements belonging to A or B or both of these. That is basically your A union B. Yes, you can check in school which way you want to write this, right? If they are fine with this or you need to write it in order. Okay. So now let's continue our discussion on union of sets. So for example, if we have these sets A, B and C, now let's see if these statements are true. So if I take A union B, is it going to be the same as B union A? What do you guys think? Is it true or false? Is A union B the same as if I take B union A? Very good. Many of you are saying the correct answer is going to be true, because it doesn't matter whether you take A union B, B union A, it's going to be again 1, 2, 3, 4, 5, 7. So in both the cases, the answer is going to be the same. So it's going to be true. Now what's the advantage of not taking it in order is that you won't miss out on any element, right? So you simply copy all these elements 2, 3, 4, then you pick up the ones that you haven't taken yet. Okay, if you try directly writing in ascending order, you might miss out some element. So please be careful of that. So this one is true. What about the next one? If I take A union B union C, is that going to be equal to A union B union C? Again, you can take a look at the examples there, and do you think this statement is true or false? What do you guys think? Very good. Yashwant is saying true, Medhani is saying true, Tejas is saying true, Anurag, true. Okay, very good. Exactly. So it doesn't matter. So basically what is this saying? That order is not important. Whether you take A union B, B union A, or you take it in this order, order is not important. So the answer is going to be true. What about the next one? Do you guys remember what is the meaning of this notation? Is A a subset of A union B in this case? This kind of notation means that A is a subset of A union B. Is it true or false? Very good. Again, the answer here is going to be true, because you will see that A union B is larger, it contains all the elements of A, so A is definitely a subset of A union B. Now let's talk about the intersection of sets. So we've talked about union of sets, now we'll talk about intersection. What is the meaning of that? Intersection of A and B, or A intersection B, is the set of all the elements which belong to both A and B, and we write it as A intersection B. So the U is basically inverted over here. It's an inverted U. So for example, let's take a look at this. If A is given as 2, 3, 4, 5, B is given as 1, 3, 5, 7, can you guys tell me what is A intersection B going to be here? What do you guys think? So those elements which belong to both A and B. So you can see 2 is not there in both, so we'll leave out 2. Is 3 there? Yes, 3 is in both of these. Is 4 there in both? No. 5? Yes, 5 is there in both. Is 7 there? No. And please write it again as a set. Please don't write the answer just as 3, 5, because A intersection B is the set of elements which belong to both A and B. Okay, so we are going to write it as 3, 5 within the curly braces, because that represents a set for us here. Clear? Now let's take a look at, so when you're doing A and B over here, so this is another example. We have 2, 3, 4, 5 and B is now 1, 6, 7, 10. What is A intersection B going to be in this case? What do you guys think? In the second example, what is it going to be? A intersection B. Very good. You guys are saying nothing. And what is nothing? Because there is no element common between A and B. Can you see? No element is common. 2 is not there, 3, you can double check. The answer is going to be nothing. How do we represent nothing in the sets? We call it a null set, remember, or empty set. So you can represent it as the null set notation, or we can write it like this. So I prefer to write this as the null set. Very good. And in this case, when A intersection B, that means there's nothing common here. When it is a null set, then A and B are called, do you know what is the term used here? These are known as disjoint sets. These are called disjoint because they have nothing in common. So now can you guys tell me, if you take two sets A and B, is A intersection B going to be the same as B intersection A? Think about the example we did, right? We did an example where we took these two sets. So does the order matter whether I take A intersection B or if I take B intersection A? Is the order important? The answer is order is not important. So this is definitely going to be true. Order doesn't matter. Similarly, you can see order will not matter here also if you take A intersection B intersection C. So you do this intersection first, then take it with that. Or similarly, if you do A intersection B first, the bracket first, and then take intersection with C. So order doesn't matter. It is true. And how about this? Take a look at the last statement. A intersection B, is it a subset of A? This notation means subset. So yes, is it a subset? True, very good. And similarly, A intersection B is going to be a subset of B. Clear? So in both these cases, again, this is making sense. This will be true. Now, of course, if one of the sets is null, then there's a special case here. Again, you can see that A intersection B will be null. Null is a subset of A, and null is a subset, also considered a subset of B. So it's still going to be true here. Now let's talk about, so we have talked about union of two sets, we have talked about intersection of two sets. Now let's talk about difference of two sets. So if we take two sets A and B, then what is the difference? This is very interesting. A minus B, difference is like we represent with the minus, so it's the same notation here. So A minus B is the set of all those elements which belong to A but they do not belong to B. So please remember it like this. A minus B means all the elements which belong to A but they are not in B. Similarly, B minus A is the set of all the elements which belong to B but not in A. Did you guys get that? So very simple. So these are the two notations, A minus B, B minus A. Now how can we write it in in this kind of set builder form? So how do we write this? A minus B is X element of A but X is not an element of B, or X belongs to A and doesn't belong to B. So this is our A minus B. Similarly, B minus A is all those elements which belong to B but they do not belong to, there's a correction here, but they do not belong to A. Alright. So if we take these two sets, A is 2, 3, 4, B is 1, 3, 5, 7. Can you guys tell me what is A minus B going to be? What do you think? So look at the definition there and see if you guys can work it out. What is A minus B going to be in this case? So A minus B means I must select all the elements which are in A but they are not in B. So let's start with 2. 2 is not in B, so definitely it will be included here. 3 is there in A but it is also in B, so I can't put it in A minus B. 4 is in A but not in B. So 2 comma 4, and we don't bother about 5, 7 because they don't belong to A. So the correct answer is 2, 4, not 2, 3, 4, because 3 is still there in B, right? So the correct answer is going to be 2 comma 4, A minus B. Now can you guys tell me what is the set B minus A? Those elements which are in B but not in A. So let's see, 1 is in B but it is not in A, so it will be in B minus A. 3 is in B but it is also in A, so I can't include it here. 5 is in B but not in A, so let's put it here. 7 is in B but not in A, so I can put it here. Is it clear? So very simple, just remember this sentence. Those A minus B is those belonging to A but not in B. B minus A those belonging to B but not in A. As simple as that. So is A minus B going to be equal to B minus A? What do you guys think? True or false? Look at the last question here. Is it true or false? The answer is it is not equal to. It is not necessary that A minus B is going to be equal to B minus A, and you can see from this example they will not be the same. Now let's talk about complement of a set. So complement is not what we normally talk in English, we say it's good to give others compliment that, hey, you did a great job, or you're wearing a nice dress. So we are not talking about that compliment. Here we are talking about complement of a set. So note the spelling, that complement, I think I'm not very good at spellings, so I think that complement has an I, if I'm correct, the English compliment when you're giving somebody a compliment, but this one has an E over here, complement. So complement of a set. So what is it? So if we take a universal set, remember, set of all the things that are in consideration. So if we are considering some universal set which we represent with this symbol, or you can use U, then, and you have some set A, then the complement of the set is the set of all the elements that are in the universal set but are not in A. So complement of A means you take all the elements which are in the universal set but not in A. That is why we call it the complement of A, and we denote it by this notation, A dash or A bar or AC. So we call this complement of A or A complement, and we say those elements which are present in the universal set but not present in A. So we can say A dash, if we use that difference notation, you can see it is matching to that difference thing, those belonging to the universal set but not in A. So it's like universal set minus A. So this is a very useful notation for you to understand. So let's take an example. Let's understand this with an example. Let's say our set A is 3, 6, 9, and this is our universal set, the set of all natural numbers from 1 to 10. So this is our universal set. So can you guys tell me what is A complement going to be here based on the definition? So A complement we represent as A dash or AC or A bar. So all those elements which are in the universal set but not in A. So again you look at your universal set, it contains 1 but A is not, A does not have 1. So I'm going to put it here. Again 2 is present but not in A. 3 is present but it is also present in A. So I cannot include that here. 4 is present here but not in A. 5 in universal but not in A. So similarly, and 6 it's present here, so I can't include it. And 7, 8 and 10. So can you guys see that this, so basically all the remaining elements, so all the elements in the universal set which are not in A. So if you take both of these, then you will get the universal set, as you can see here. Very good. Now let's talk about overlapping or intersecting sets, or what we say as joint sets. So this is like the opposite of disjoint, which we briefly talked about. So we take, if two sets A and B, they are called overlapping or intersecting sets or joint sets if they have at least one element in common. For example, let's say we take two friends. Okay, so let's consider there are two friends and we ask you to list down your hobbies. Okay, we say that list down your hobbies. Now those two friends, if they don't even have a single hobby in common, then they will become not overlapping. But if let's say they have one hobby in common, let's say they like to play chess, okay, or they like to watch soccer, football. So that is their hobby, or they like to play football or soccer. So that means there is overlap. That is the meaning of overlapping. That means at least one element has to be common between the two sets. So here of course in sets we are not talking about hobbies, usually we are talking about numbers. So if we take these two sets A and B, can you guys tell me, are they overlapping sets? Are they overlapping sets? Do they have something in common? Yes, you can see the element 2 is common, element 4 is common. Okay, so clearly you can see, and common means we say intersection, right? So you can see here that A intersection B is going to be those common elements 2 and 4. So definitely these two sets are overlapping. The answer is going to be yes. So when are sets non-overlapping? When A intersection B is not null. That means you can get some intersection. If A intersection B is null, that means they have nothing in common. They are not overlapping. For example, if two friends, they do not have any common hobbies, then we say they are not overlapping. They are not intersecting. Is this clear? So that is exactly what we are discussing, non-overlapping set, or what we call as disjoint sets. Nothing in common. So two sets are called disjoint if they have no element in common. Can you see here, no element is in common. So we say A intersection B is basically the null set. So if you look at this example now, 1, 3, 5, B is 2, 4, 6, 8, are they disjoint sets or are they non-overlapping? What do you guys think? So again look, take their intersection, do you see anything in common here? You can see there is no element common. Those are odd numbers, these are all even numbers, nothing is in common here. So the answer is they are disjoint. Definitely they are disjoint. Operation on sets. So we have discussed many operations. Now let's look at some important notes here, that if you take any set A, so let's see if these usually, more than learning it from your textbook, or if it's being taught in school or given in your textbook, first understand it. Don't try to just memorize these as formulas. These are not formulas. Just think of an example and let's see if we can do it with common sense. So if I take A as any set, you can imagine any set of numbers, let's say 1, 2, 3 or 1, 3, 5, right? Anything. And if you do the union with the null set, then what will you get? So if you're combining, if you're doing union with nothing, then you're going to get that set back again. So A union null is going to be A. Does that make sense? Okay. What about if I do A union the universal set represented with this funny curly looking E, or usually that's why we don't write U here because it will get confusing, capital U. So what will you get? A union the universal set. Now universal set is the universal set does not mean set of all numbers or something infinite. It means the set of all the things that are in consideration, like let's say the set of books in your library, or set of numbers, let's say from 1 to 10, whatever. So if you take with the union, because all the elements of A are already included in the universal set, so here the answer is simply going to be the universal set. And what is A union A going to be? So if you take A as 1, 2, 3, if you do a union with it, you're going to get the same thing, because in a set you don't repeat the elements, you don't write 1, 2, 3, comma 1, 2, 3. They all have to be unique. So A union A is going to be A. Fantastic. So you can see these are very easy. So don't learn them. Understand them with an example and you'll be able to solve it, you remember it. Okay. What about this? A intersection null. So if you take some set A, again think of an example, let's say 1, 2, 3. And I want to find what it has common with the null set. But hold on, null set has nothing. So A intersection null will obviously going to give you null, nothing. What about A intersection the universal set? So let's say A is 1, 2, 3 and universal set is natural numbers from 1 to 10. So 1, 2, 3 intersection that, you're going to get back 1, 2, 3. So you're going to get back E. Similarly, A intersection A is going to give you A because it has all the elements in common with itself. So very simple. Now what if I ask you what is the complement of the universal set? What is the complement? I'm not sure if you're able to see this dash clearly here. So there's a dash here which we call as complementary. Either you can put a bar or you can write a C. So complement of the universal set, but universal set we have already taken all the elements. So what lies outside it? Nothing. So this is basically going to be null. And complement of the null set, complement of the null set means is going to be the universal set, because null means it has nothing. So complement means all the things other than nothing, they are the universal set. So universal set is representing all the things that are in consideration. You don't have to write A or B here, we write universal. Okay. Some of you may be thinking that complement of null is going to be A or B. No, it's going to be the universal set. And complement of universal is obviously null. Now if A is any set, then A union A complement, what is that going to be? So think about it. If you have taken A as 1, 2, 3 and A complement was all the numbers we took universal as 1 to 10. So all the numbers other than 1 to 3. So it's going to be 4, 5, 6, 7, 8, 9, 10. Now if you join them, what are you going to get? You are going to get the universal set. Very good. Because union is joining. So if I join all the things in A and all the things outside A, I'm going to get everything here. So which is basically the universal set. A intersection A complement. Note this carefully, this is complement. So what does A and A complement have in common? A complement means all the things not in A. So nothing is in common, null set, very good. So we write it as this or this, basically null set. Now if you take A and B are any set, so these are all the important points as we have discussed. A will be a subset of A union B, B will be a subset of A union B, right? And A union B is a subset of the universal set, because universal set contains everything. Okay. Now it might be that A union B could give everything including that, right? So you could put a equal to also. So it either could be a proper subset or we might have to include this. So that depends. Similarly here, if B is null, right? So maybe they are going to be equal. So do you guys get that notation between a subset or equal to set? Equal means identical. So those things can take place here, but to make it easy, we can just write it like this for now. Similarly, A intersection B is subset of A intersection B is going to be a subset of B, and A minus B, this is very interesting. So think about this with an example. A minus B, what did we say? Difference of two sets? All the elements which are in A but not in B So look at the left hand side. A minus B, all the elements which are in A but not in B. Now let's look at the right hand side. A intersection B complement. All the elements in A and intersection means and all the elements that are not in B. So are you guys getting that? So isn't it the same thing? All the elements which belong to A but not in B. And here the same thing we are saying, all the elements which are in A and not in B. So these are the same thing. So this is a very interesting way. Either you can write it in terms of difference or intersection. Similarly, B minus A is going to be B intersection A complement. So think this with an example and you will understand it. Now if A and B are two sets, and we have discussed this, if A and B are disjoint sets, then when are they disjoint? If A intersection B is null. So this is the rule for disjoint. That means they should have nothing in common, absolutely nothing in common. And these are overlapping sets. So sets have, if they have something in common, when A intersection B is not null. So simple, opposite of each other. Now let's look at the commutative laws, right, which we talked about. So you guys know that time I didn't mention the name. A union B is B union A. This is called commutative property. Just like we say x plus y equals y plus x. If you take two numbers, do you guys agree? X plus y is y plus x. That means commutative, order doesn't matter. Same thing in sets. A union B is B union A. Similarly, A intersection B is B intersection A. So the key thing here is order does not matter. So we say that this union and intersection operations, these are commutative. Next, let's talk about the distributive law. What is the meaning of distributive? The union is distributive over the intersection of two sets. Let me first explain this with a simple example before we talk about sets. So let's say if I tell you, if we take x multiplied by y plus z. So what can I write this? Can I do this as x multiplied by y plus x multiplied by z? Do you guys agree? Do you guys agree? So we can say multiplication is distributive over addition, just like we have done in algebra. Multiplication is distributive over addition. Same thing over here. Of course, we are not going to write multiplication and addition. We are dealing with union and intersection. So if you are taking again, now in commutative we took two things, in distributive you have to take three things, like we took x, y, z here. Similarly, we are taking A, B and C. So if A, B and C are three sets, we can say A union B intersection C, okay, is equal to A union B intersection A union C. Do you guys agree? Look, compare it with this line. Isn't it looking similar? So we can say union is distributive over intersection. Right? It's similar. Very good. So now how do you verify this? Very simple. You just write this down and do the left and right hand side. So what do we need to verify? We need to verify that A union B intersection C is going to be, if I do A union B first and A union C, and then I take the intersection. So how do you check this? Very simple. You first solve this. You solve B intersection C. What is it going to be? So let's look at the left hand side first. LHS, we are going to solve B intersection C. And how much is that? If we take B intersection C, what are the common elements? You can see it's going to be 6 and 8. So can you guys help me here? 6, 8, right? And if I do the union with A, so A union B intersection C, so 6, 8 and all of these. So what will I get? So 2, 5, 6, 8, 11. So this is my LHS. Now let's look at the RHS. So now you solve these parts. So first do A union B. What are you going to get? So all the elements in A or B or both. So we are going to take 2, 4, 5, 6, 8, 11. That is A union B. What is A union C? A union C is 2, 5, 6, 7, 8, 11. So what is the intersection of these? Check it. What is the intersection of A union B intersection A union C? Are you going to get 2, 5, 6, 8, 11? Check it. Yes, 2, 5, 6, 8, 11. See, we have proved it. So this is how you verify. Just take the left hand side, right hand side, and remember, when the bracket is given, you must solve the bracket first. The law of BODMAS, right? Solve the bracket first and then you do the union with A. Similarly here, you solve the brackets first, then do the intersection, and you will get both the same, which is proving that union is distributive over intersection, just like multiplication was distributive over the addition. And similarly, you have the other law also, that intersection is distributive over union. But note that addition is not distributive over multiplication, so don't match it with this one. But for sets, both are true, just like union was distributive over intersection. Intersection is also distributive over the union of two sets. So if you take a look here, intersection is distributive over the union, which means A intersection B union C. Whether you do A intersection B first, A intersection C, and take the union, you're going to get the same thing. So how do you verify? Again, same trick. You just solve the LHS first, then solve the RHS. So you guys can try this on your own, and then you prove it. Which means you do this bracket first, then take the intersection here, do these individual brackets, take the union, and you're pretty much done. Clear? So all of you can try this one. Now let's talk about De Morgan laws. These are my favorite. It's very, very interesting law. What does De Morgan's law say? The complement of union of two sets is equal to the intersection of their complements. Looks complicated, but I'm going to make it very easy for you. So what does his law basically say? That if you take A union B, okay, so let's write it like this. If you take A union B and you want to take the complement of this. Complement here doesn't mean telling something good. Complement means opposite. So all you need to do, please follow me carefully. If you're doing complement of A union B, you start taking complement of each thing. So what does that mean? You take the complement of A, so we are going to write it as A complement, which means all the things in that are not in A. Then what is the opposite? So complement is like opposite, so A complement. Then what is the opposite of union? It's like this thing, smiley, you turn it into a sad thing, intersection. So opposite of union is going to be intersection. And then again you take the opposite of B, which is going to be B complement. So can you guys see that? So see, exactly the same. So all you have to do is just keep taking opposites. A complement, you take unions complement, which is intersection, B complement, done. Clear? So that is why he says it is equal to the intersection of their complements. Similarly, the opposite one. If you take A intersection B's complement, what did we say? We are going to take A complement, then we are going to invert this, that will become a union. We are going to take B complement. There you can see. So this is my favorite law, where basically all you need to remember it, just keep taking the complement, including that operation. Union becomes intersection, intersection becomes union. Is this clear? And how do you verify De Morgan's laws? So what will you do here? Same thing, you are going to be taking, now for verification, since we are taking complements, we must include a universal set. So let the universal set, let's say it's numbers greater than, natural numbers greater than 5, less than equal to 15. And it's given to us that set A is a set of even numbers, set B is the multiples of 3. So clearly our universal set is going to be this one. This is our universal set here, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Now what is A going to be? If I tell you A is the set of even numbers, does that mean all the even numbers? All the, let's say we are taking all the natural numbers 2, 4, 6, 8, 10. Do we take all the even numbers? No. We need to take only those even numbers which are present in the universal set, because universal set is like our universe of what we are considering. So 6 till 14. Note, this is very important. You must take only elements that are present in your universal set for that question. Similarly, B is only those multiples of 3 present in the universal set, not all the multiples. Okay, very important. Now you guys, now to prove it, remember same trick, you have to solve the left hand side and prove it equal to the right hand side. So please find A union B. So you take the union of this, then find the complement of that, which you're going to get here. So this is like your LHS, this is like my left hand side, and for the right hand side you work out A complement, B complement. So please work that out here. So please find out what is A complement, what is B complement, and find the intersection of that, and this is basically your RHS. And you can easily verify that LHS equals RHS, 7, 11, 13, they are identical. Similarly, you can verify the other De Morgan's law. A intersection B complement is A complement union B complement. Is it clear? So very simple, you just have to take left hand side, right hand side and just verify it. Okay, with some example. Obviously, you cannot take some imaginary set. You take a universal set, A complement, A set, B set, and then take your complements. Very simple. And last thing we're going to talk about today, cardinal property of sets. So remember, what is the cardinal number? It is the number of elements in a set. So similarly, we can say that if you are taking two sets A and B, and some of these things will become more clear when we talk about Venn diagrams in the next class. Okay. So for example, if you visualize something like this, let's say you have two sets. So if you guys have done the Venn diagram notation, it looks like these circles. Okay. So let's say we have two sets A and B, and they are containing these elements 1, 3, 7, 8. In the intersection we have 2, 5, and here we have let's say we have 6, 10, 12. Okay, so that's our example. Intersection means this is our intersection part, what is in the middle here. So let's go ahead and check if this formula is working. How many elements do we have in A union B? A union B means all the elements in A or B or both. So how many elements are there? Let's check. So number of elements of A union B. How many do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, all of them. So this is my left hand side. What is in the right hand side? What is the number of elements in A? So all the ones in the A circle, again all this Venn diagram notation we'll do next time, but just to visualize it, 1, 2, 3, 4, 5, 6, number of elements is 6. Number of elements in B, how many elements do we have in B? We must include this also, 2, 6, 5, 10, 12. So we have 5 elements in B. How many elements we have in A intersection B? 1 and 2, we have only 2 elements here. So can you guys add it up and see if it's working out? If you take number of elements in A, 6 plus 5, that's 11 minus 2, see that's exactly equal to 9. So RHS is going to be equal to 9, which is the same as LHS. Now how is this magic working? Please take a look, because what is this saying? If you take all the elements in A or B, what will it be? You take the add up the number of elements in A plus in B, so you add them up. But since when you're going to be taking this, can you see that you're counting the 2 and 5 twice? So that is why we have to subtract it once. We have to subtract the intersection once. So if you're taking the number of elements in A or B, it is number of elements in A plus in B, but we have added the common one 2 times. So that is why we subtract it once. And that is how this formula comes. Clear? So once you practice these sums, this is going to become much easier, and we'll talk about Venn diagrams next time. Do check out the other courses on our website if you haven't done so already. We have physics, chemistry, biology and maths for CBSE and ICSE boards, classes 8, 9 and 10. We have physics and chemistry for Cambridge, classes 9 and 10, the IGCSE board. And if you guys want to learn coding, we have Java and Python coding for all classes.